Okay, now this is just an overview of roots and coefficients of quadratic equations first, but in this exercise, exercise 12.6, which is in the extension 1 chapter on polynomials, we review roots and roots of sums and products of roots of quadratics, and then we move on to cubic equations and quartic equations. So just looking at what we looked at last lesson, the quadratic equation ax squared plus bx plus c equals 0. Now I can write that in monic form by dividing through by a. So if I divide each term by a, I'll get x squared plus b on a, x plus c on a equals 0 on a is 0. So remembering last lesson we said, like, if the roots of the quadratic equation are alpha and beta, then the equation can be written as like this: x minus alpha times x minus beta is 0. This is in monic form. Expanding that, we get x squared minus beta x minus alpha x plus alpha beta is 0. Collecting the like terms and factorizing out the negative x, we've got negative x bracket beta plus alpha, or alpha plus beta. And here we've just got our constant term alpha beta. If we compare this, which is in monic form, to this up here, this form of the quadratic equation in monic form, we can clearly, we can write that x squared plus b on a, x plus c on a equals, or is equivalent to, x squared minus alpha plus beta x plus alpha beta. And this is just another way of showing that, remember our sum of roots. So our sum of roots, which is alpha plus beta, is minus b on a, and that our product of roots, which is alpha times beta, is c on a. So we can see that for any quadratic equation, ax squared plus bx plus c is 0. Sum of roots, if I compare these two, I would have to say that the alpha plus beta, I would need minus b on a here to be equivalent to that. Sorry, now what we've got is b on a equals negative alpha plus beta, so alpha plus beta, so just there, sorry. What I've got, if I'm just comparing the coefficient of the x terms, I've got b on a equals negative alpha plus beta. So in other words, alpha plus beta is negative b on a. So we can see that from here, from equating these two sides, okay, which is what the result we achieved yesterday. And we can see product of roots, they're both positive, so that's fine. Alpha times beta is c on a. Now, cubic equations, we were looking at factorizing these last week, and so this week we're just looking at again using sums and products of roots for cubic equation. So the cubic equation would just start off the same way: ax cubed plus bx squared plus cx plus d equals 0. So we always start with a, b, c, d. The x cubed term, the x squared term, the x term, and the constant term. Now this can also be written in monic form by dividing each term by a to give us this: x cubed plus b on ax squared plus c on ax plus d on a is 0. Now, remember, with a quadratic equation, we said that it had roots alpha and beta. A cubic equation has roots alpha, beta, and gamma. So let's say our cubic equation has those roots, alpha, beta, and gamma. Then the cubic equation in monic form, so this is in monic form, can be written as x minus alpha bracket x minus beta x minus gamma. I'll expand the first two brackets together. I'll just do these two first. I've got x squared minus beta x minus alpha x plus alpha beta, and then multiply it by this second bracket here. I'm multiplying each term in the first bracket by each of the terms in the second bracket. I end up with this expression here. Now I'm just going to collect like terms. So I've got 1x cubed. My x squareds are this term, and this one, and they're all negative. So I've got minus. Now I've got alpha, beta, and gamma. So they'll all be positive because I've taken out the minus. So I've got x cubed minus alpha plus beta plus gamma times x squared. And then just looking at the x terms, I've got 3 x terms. Actually, I just need to check this one because I actually think that this one is positive. And it is, so I've got those two. That's positive, this one's negative. This is negative, this one is actually positive, plus beta. It's that times that, which is plus beta gamma x. Okay, so looking at these 3 x terms, we've got a plus x in common. I'm just going to put that x at the back, okay? But then we've got I'm just going to try and do them in some sort of order. Alpha beta times x, alpha gamma times x, and beta gamma times x. So I've got alpha beta plus alpha gamma plus beta gamma all times x, and then minus, and my constant term here is alpha beta gamma. Now, we can compare these two forms of the equation. So now, saying that x cubed minus alpha plus beta plus gamma x squared plus alpha beta plus alpha gamma plus beta gamma times x minus alpha beta gamma, that is equivalent to, because this is the expansion of the factorized form of the polynomial, and this is just the normal cubic equation divided through in monic form, which was divided through by a. So I can say that this expression here, which is that, equals this, which is x cubed plus b on a x squared plus c on a x plus d on a. So we can say that those two expressions are equivalent. Now, you can see in front of the x squared I have, so what I can do is equate, and I can say, well, I can say negative alpha plus beta plus gamma is b on a. In other words, that means that alpha plus beta plus gamma is negative b on a. Now, alpha plus beta plus gamma is sum of roots one at a time. So we call this sum of roots one at a time because it's just the single roots added together. So I can say that that is my sum of roots one at a time. So sum of roots one at a time, alpha plus beta plus gamma is minus b on a. Looking at the coefficient of the x, so the c on a here is equivalent to alpha beta plus alpha gamma plus beta gamma. Now that is the sum of roots, but grouped two at a time. So we write that as sum of roots two at a time. It's all the combinations of alpha, beta, and gamma. So it's alpha beta plus alpha gamma plus beta gamma. Now, as I said, comparing the coefficients of the x terms, okay, and they're both plus, that means that alpha beta plus alpha gamma plus beta gamma has to equal c on a. So sum of roots two at a time is c on a. Now, I want to go back to product of roots. Product of roots for a quadratic was also c on a, and it is actually two at a time as well. The product of the roots, because there's only two roots, is two at a time. So sum of roots one at a time here, alpha plus beta is minus b on a. This time we call it, you could call it sum of roots two at a time, but there's only one product. It's actually the product of all the roots. So alpha times beta is c on a, but there are two roots multiplied together to give you c on a. Same with your cubic, right? With your cubic, when you're adding the roots together one at a time, it's minus b on a, and that's called sum of roots one at a time. And sum of roots two at a time are all the different combinations of alpha, beta, gamma together. Alpha, beta, alpha, gamma plus beta, gamma. That's c on a. And sum of roots three at a time. Now, sum of roots three at a time is just alpha, beta, gamma. Okay? So now, if negative alpha, beta, gamma is d on a, then alpha, beta, gamma is negative d on a. So that's alpha, beta, gamma. That's negative d on a. Now, sum of roots three at a time is really just the product of your three roots. Okay? All right, so again, with a, just going to summarize what we've got so far. With a quadratic, seeing the similarities, we've got alpha plus beta, which is one at a time, is minus b on a, and alpha times beta is c on a. With a cubic, we've got alpha plus beta plus gamma, which is one at a time, is minus b on a. And we've got alpha beta plus alpha gamma plus beta gamma is c on a, so that's two at a time. And we've got alpha beta gamma is negative d on a. Okay, so it goes from negative to positive. Again, with the cubic, one at a time, negative b on a, two at a time is c on a, product of roots, or three at a time, is minus d on a. We can also do sums and products of roots of quartic equations and any other degree of equation. So we're just going to do the quartic equations as our last one. So the quartic equation, which has power of 4, is ax to the power of 4 plus bx cubed plus cx squared plus dx plus e equals 0. That can also be written in monic form by dividing through by each term through by a to give us x to the power of 4 plus b on ax cubed plus c on ax squared plus d on ax plus e on a is 0. Now, if the 4 Greek letters that we give to quartic equations, the 4 Greek letters we give to the roots of quartic equations are alpha, beta, gamma, and delta. So if a quartic equation has roots alpha, beta, gamma, and delta, then the quartic equation can be written in monic form as x minus alpha, x minus beta, x minus gamma, x minus delta equals 0. Now I could expand this. You can actually go to your textbook and see it at the beginning of 12.6. It's all expanded and like terms are collected. But look, you can tell just what your leading term is. It's going to be x to the power of 4. We can tell what our constant term is. That's going to be negative alpha times negative beta times negative delta times, negative gamma times negative delta, which is, here is our last term, alpha, beta, gamma, delta. There's our leading term. Okay, our coefficient of x cubed, when this is all expanded out, we end up with we will end up with like alpha x cubed, negative alpha x cubed, negative beta x cubed, negative gamma x cubed, and negative delta x cubed. And then when we collect all the x cubed terms together, we get minus alpha plus beta plus gamma plus delta. Notice these are sum of roots one at a time. Notice now, if I have 4 roots, if my 4 roots just over here, so sum of roots, if my 4 roots are alpha, beta, gamma, delta, sum of roots one at a time would be alpha plus beta plus gamma plus delta. Sum of roots 2 at a time, I have to do all the combinations. So I do alpha with beta, alpha with gamma, alpha with delta, as you can see here. Alpha with beta, alpha with gamma, alpha with delta. So I've done all the combinations with alpha, then we do the combinations with beta. Beta with gamma, beta with delta. See, beta with gamma, beta with delta. And so I've done all the alpha combinations and I've done all the beta combinations, and the last combination is gamma times delta. Now, some of these are the sum of the roots 2 at a time, and if you do expand and collect all like terms, you'll find that these are all the coefficient of the x squared terms. And then sum of roots 3 at a time, so you would do any 3 at a time. So you miss out delta first time, you can miss out gamma second time, you can miss out beta next time, and you can miss out alpha on the last one. So notice this is missing the delta, this is missing the gamma, this is missing the beta, and this is missing the alpha. So this is the sum of roots 3 at a time, and there are 4 of those. And if this was, like I said, all expanded, these would all be the coefficient of the x, and these would all be negative as well. So, and then that is my sum of roots 4 at a time. So what we did before, just equating this equation down here, so this is equals 0, okay? So equating this equation here with this equation there, looking at the coefficient of x cubed, so negative alpha plus beta plus gamma plus delta is b on a. That means that the sum of roots, 1 at a time, which is alpha plus beta plus gamma plus delta, is negative b on a. Now remember, in a cubic, sum of roots 1 at a time, and a quadratic, was also negative b on a, sum of roots 1 at a time, no matter whether there are 2 roots, 3 roots, or in this case 4 roots. Now, sum of roots 2 at a time. So sum of roots 2 at a time, we know, is all the different combinations of the 4 roots. So we've got alpha with beta, alpha with gamma, alpha with delta, beta with gamma, beta with delta, and gamma with delta. Okay, now they equal, as we can see here, the x squared, coefficient of the x squared equals c on a. So notice it always starts with minus b on a, then it goes to positive c on a. Then we've got sum of roots 3 at a time. Now, these are all the combinations of alpha, beta, gamma, delta. So we've got alpha, beta, gamma, I've missed delta, So we've got them here, plus alpha, sorry, that's not an alpha, alpha, beta, gamma, plus alpha, beta, delta, plus alpha, beta, sorry, no, alpha, beta, alpha, gamma, delta. So here I've missed the delta, here I've missed the gamma, here I've missed the beta, and plus, I'll miss the alpha in the last one, plus beta, gamma, delta. Now so that's the coefficient of the x, and it's negative of that. The negative of that equals d on a, so therefore that equals negative d on a. And sum of roots 4 at a time, but in this case, sum of roots 4 at a time is actually what we call the product of roots. So because this is a quartic and there are 4 roots, when you sum the roots 4 at a time, you end up with the product of the roots. So that's alpha times beta times gamma times delta. That equals E on A. So just looking again, 1 at a time minus B on A, 2 at a time C on A, 3 at a time negative D on A, 4 at a time E on A, going from negative to positive to negative to positive, starting with B, then C, then D, then E. Okay, always starting with minus B on A, look at your cubic as well and your quadratic. Minus B on A for 1 at a time, then C on A, then alternating negative, positive, negative for your cubic minus D on A. Okay, hopefully you should be able to remember those. Here, so if alpha, beta and gamma are the roots of this polynomial equation, which is a cubic, so 2x cubed minus 5x squared plus x plus 1. Find alpha plus beta plus gamma. Now that's sum of roots 1 at a time, which is minus b on a. Now just writing over here what a, b, c and d are. A is 2, b is negative 5, c is 1 and d is negative 1. Just making sure that you see that clearly before you start. So this is sum of roots 1 at a time is negative b on a, so it's negative negative 5, which is positive 5 over 2. Now, remember we've got 3 roots, alpha, beta and gamma. So this is all the 3 combinations. This is sum of roots 2 at a time. So alpha, beta plus beta, gamma plus alpha, gamma is C on A. Now looking over here, C is 1 and A is 2. So that's a half. And this is the sum of roots 3 at a time or product of roots. And we know that that is negative D on A, because we go minus B on A, C on A, negative D on A. So that's negative negative 1, which is positive 1 over 2 as well. I can write these as negative negative 5 on A, which is 5 on 2, negative negative 1 on 2, which is a half, if you want to show a working. Now, part D, find alpha plus beta plus gamma all squared. Now we know what alpha plus beta plus gamma is. It's 5 on 2, so this is just 5 on 2 squared. Which is, so you don't need to expand that, which is 25 over 4. This next one, alpha plus 1 times beta plus 1 plus gamma plus 1, you're going to have to expand that. So expanding the first 2, I've got alpha, beta plus beta plus 1. That's got to be multiplied by gamma plus 1. So that will be alpha, beta, gamma plus alpha, beta plus alpha gamma plus alpha plus beta gamma plus beta plus gamma plus 1. So having a look at this, we've got alpha beta gamma plus, and we've got sum of roots 2 at a time, alpha beta plus alpha gamma plus beta gamma. Then we've got plus the single roots, alpha plus beta plus gamma plus 1. So we know the values of all of these. So sum of roots 3 at a time is a half, because alpha, beta, gamma is a half. Plus sum of roots 2 at a time is also a half from up here. Plus sum of roots 1 at a time is 5 on 2. And plus 1. So we've got 5, 6, 7 over 2 plus 1. Now that's 3.5 plus 2, which is 4.5, or 9 on 2. Okay, and now for the last one, 1 on alpha plus 1 on beta plus 1 on gamma. We did something similar to this when we were doing the reciprocals with the quadratic equations. Again, we need a common denominator. So the common denominator is going to be alpha times beta times gamma. This fraction is missing beta times gamma. So this we multiply by beta gamma over beta gamma. This is missing alpha gamma. And this last one is missing alpha beta. Now we can see, so we've written that now as a single fraction with a common denominator. We can see that this is sum of roots 2 at a time on the numerator. Now sum of roots 2 at a time is a half. Okay, and product of roots, alpha beta times gamma. So product of roots is also a half. So it's a half divided by a half, which is 1. Or you could write it as a half divided by a half, which is a half times 2 over 1. Okay, remembering, and then cancelling. But anything divided by itself is 1. Okay, if 1 root of x cubed minus x squared plus 2x minus 3 equals 0 is 4, find the sum and product of the other two roots. So let the roots be, now we know that normally it would be alpha, beta and gamma, but because we already know that one of them is 4, so we'll go 4 alpha and beta. Okay, so now we can say the sum of roots, now this will be 1 at a time. Sum of roots 1 at a time is 4 plus alpha plus beta, and that's negative b on a. Now looking at our equation, we've got that a is 1, b is negative 1, c is 2, and d is negative 3. So sum of roots, this is 1 at a time. Sum of roots 1 at a time, which is 4 plus alpha plus beta, that's negative b on a. So I've got 4 plus alpha plus beta, and negative b on a is negative 1 on 1, which is 1. So therefore alpha plus beta, that is 1, take away 4. Alpha plus beta is negative 3. So that's the first part of the question. The sum of the other two roots is negative 3. Now for product of the other two roots, I'm just going to do product of roots rather than sum of roots 2 at a time. So product of the roots, which is alpha times beta times 4. So that's 4 times alpha times beta, or alpha times beta times 4 is, remember that's negative d on a. So 4 alpha beta is now negative d on a, that's negative 3 on 1. So we've got that 4 alpha beta is 3, therefore alpha times beta is 3/4. So that is the product of my other two roots. And so therefore the sum of the other two roots equals negative 3, and the product of the other two roots is 3/4.